Hi, it's Emma Math. Easy solution here to discuss some derivative applications. Look at the rules that I showed before of derivative, and I'm going to apply it to some distance and this velocity example that I got from my textbook somewhere. That's pretty useful. This is my calculus textbook from first year in calculus 101 and 100. So basically, this is, let's say, a distance function of a particle. Let's say it's just going either moving forward or backward with time. So that's all it's kind of doing like that. So basically S is in, let's say, meters and T is in seconds. We'll just give them these units. So now let's solve these questions. Say for part A, what is the velocity? So velocity, I showed my other video, is basically the slope of any function is the rate change of that function. So in this case, S, which is in meters, the rate of change, delta S over delta T. This is just basically meters over second, and that's all velocity is. This is velocity. This is basically the rate change of distance or of displacement or whatnot. So then as we take the derivative or the instantaneous change, that's just, that is what derivative is. So in this case, S prime is equal to v of t. So this is a velocity, instantaneous velocity, just going to be equal to the derivative of the function we have over dt. And if we just solve it using our the derivative rules I showed, the power rules can be put the 3 down, subtract by 1, 2, and this is 12, or bring it 2 times 6 is 12 plus 9. Derivative 9t is just 9. Okay, so so basically there's our velocity. So now let's solve for b. B, what is velocity after 2 seconds? At t is 2 seconds. V of t, or v of 2, is going to be equal to 2 squared minus 12 over 2 plus 9. And then if we just solve for this one, it's going to be 3 times 4. This is minus 24 plus 9. This equals 12 minus 24 plus 9. And this equals 12 minus 24 is negative 12 plus 9. This is going to equal to negative 3 meters per second. And the negative means it's moving backwards in this application. Backwards. And then if it's positive, it's moving forward. And then also after 4 seconds, let's see, after 4, t equals 4 seconds, then v of 4, if we just plug it in. So I already did it before. I already put in the calculator here, so 3 times 4 squared minus 12 times 4 plus 9 is equal to 9 meters per second. 9 meters per second. So basically, it's moving forward at a faster rate than it was moving backwards at t is 4 than it is t is 2. So we got that. Let's solve for D. When is the particle? Oh no, I mean C. When is the particle at rest? So at rest is basically when it's not moving or the rate of change is 0, and that's just basically at v equals 0. And then so all we do is set it to equal to 0 and solve for t. So we find at what time it's not moving. T squared minus 12t plus 9. So basically now we just simplify this one, just divide the 3 out, we'll have 0 divided by 3 is 0. Cancel the 3's is t squared minus 4t plus 9. So, and then now we can either do a quadratic formula to solve for t, or just complete the square. You see my other video on completing the square. So basically what it means is if you have, let's just say a function like x over b over 2 squared, if you square this one out, it's going to be, so basically x squared, and then if you expand this out, this is going to be negative b times x, and then this is going to be, well, plus b over 2 squared. When you square the negative, it's going to be cancelled. So in this case, all we do is we make it look like it, so we'll have 0 equals t squared minus 4, in this case that's b, and then we'll just have a b squared, b over 2, so 4 is the b divided by 2, so 4 divided by 2 is equal to 2. So in this case, all we're going to do is, so we add 2, subtract by 2, so all we do is add this little section here. So we're going to have 4t plus 2 and then no, I mean, yeah, this is 4 over 2 is 2. Then we got to square this one. So square equals to 4. So we add 4. So we added 4, but then so now we added 4. Then we also subtract by 4, and then just add this negative. So we're not really changing anything. And then this one here, based on this little completing the square thing, you can see a better explanation in my other video on completing the square. So this one's going to be, well, this is just going to be t minus b over 2. In this case, 4, so t squared. And then this is plus 9. 9 minus, it's negative 4 plus 9, which is just, actually, yeah, this is not 9. I forgot to divide this by 3. This is actually 3. So then negative 4 plus 3 is just going to be negative 1. It's going to be negative 1. And then if we just rearrange it, 1 equals to t over t squared. Now if we square both sides, we'll have, again, 1. So 1 squared is 1 is that. And this 1 is going to be a plus or minus, because if you square root, well, basically if you have x squared equals 1, if you square both sides, it's going to be something like, yeah, it's going to be plus or minus 1 equals x, because if this is negative 1 squared, it's going to be 1, so you need to plus or minus here. T minus 2. So then, so we'll have something like this, and then basically this is going to be, so we're going to have two values of t in this case. So if we have 1 equals plus t minus 2, yeah, with the plus minus we could shift it here, because if it's a negative, we just divide this by negative 1, divide by negative 1. So we could actually, yeah, so we're going to have, for range, it's going to be plus or minus 1 is equal to t minus 2, and then if we rearrange it, t is equal to 2 plus or minus 1, and this is going to be equal to either 3 or 1 seconds. So it's at rest at, rest at t equals 3 and t equals 1 seconds. Yeah, so we solve that. You can always use a quadratic formula to solve that. So now draw a diagram to represent the motion of the particle. Well, so we could either draw it or just use a graphing calculator. So just go graphing calculator. So we grab this out here. Let's just graph that equation, which was, so basically t over 3 minus 6 t squared plus 9t. Let's just make it for 0 to, let's say, 5. You can do this with the graphing calculator in Google, which is amazing. No, not 4. We write from, actually. I think that's what it was. From 0 to, yeah, so we have it from 0 to 5 seconds. This is pretty amazing. And so yeah, so that's how it looks like. So basically at 1, its velocity is 0, the slope is 0, and at 3, slope is 0. So it goes up to 4, it goes back to 3, and then it just zooms back up there. And so basically so it's going to look something like this then. If this is s and this is t, basically slope is 0 here. This is at 1, this is at 3, and at 0 it's nowhere. This is 0, and this is at 5 seconds. It goes up. So there's that, and then let's say so let's see what E was. You find the total distance traveled by the particle during the first 5 seconds. Okay, so basically the total distance. In this case, we look at, so it stopped here. So let's just say, what is this total distance? So we're gonna have to go s of 1, and then so it walks all the way up here, then walks backwards. So s of 1, and then it walks backwards. It's gonna be the same thing. So we could just plus s of 1 here, and then it goes up all the way here, which whatever this is, and that's just s of 5. So s of 1 is going to be equal to, let's just write s of 1, or the distance at 1 second, is equal to, what is the equation? T3 minus 6t plus 9. So we'll have 1, 3 minus 6, 1 plus this is squared, and then yeah, plus 9 times 1, just to solve for this one, is going to be equal to 1, minus 6 plus 9, this one's going to equal to 3, that's just 4. So then s of 5, what is that one equal to? This is equal to 5 cubed minus 6 times 5 squared plus 9 times 5. Put this in the calculator. Notice that I don't like calculating things manually. So we just solve this one. 5 cubed minus 6 times 5 squared plus 9 times 5. This one's equal to, well, 20. Okay, so basically this is equal to 20 meters. And yeah, this is 40 meters. So basically from this graph, we saw that it goes up 4 meters. This is 4. Goes down 4. Or negative 4, whatever, goes up 20. So the total distance, this doesn't matter. But, so it goes up or down, so he's still walking. So total distance is just the total amount of walking, or does we just sum it up? So this equals to 4 plus 20, and this equals to 28 meters. So there's a little quick application of using this. I'll show you some more later, but this is pretty useful. So yeah, velocity is just the rate change, and yeah, you could use quadratic formula here, but I just like using this little quick completing the square. Once you get a hang of it, it's really useful. You don't need, all you need to do is memorize this, and you can prove it yourself easily. Well, thanks for watching, and stay tuned for another math easy solution.